Hey everyone, welcome to section 7.7, our last new material of intermediate algebra. We're going to cover proportions and variation today. So let's get started. So our objectives, we're going to solve proportions, solve direct variation problems and inverse variation. And then again, we're going to be kind of skipping a couple of things here at the end, just due to what I want to get through this semester. So a proportion, what is it? Well, we kind of covered them last section in 7.6, but we're going to, maybe go into a little bit more detail this section. So a proportion is a statement or an equation that two ratios or fractions are equal. So basically you can say two equal ratios. So two ratios are equal. So again, we kind of talked about this property last time. But the following property is basically a way that you can solve a proportion. So if you have a fraction, which is also known as a ratio, A over B equals C over D, we could then cross multiply, right? We can take this A times D and set it equal to B times C. So that's called cross multiplication. And that's when we have the equal sign. Okay, so it's a little bit different. Again, it's different than when I have A over B times C over D, where this one we do A times C over B times D. That's not the same thing as a proportion. A proportion we cross multiply. All right, so and then again, as always, when we have a rational expression, our denominators can't be zero. All right, so for example, if I have an elliptical machine, Francis can burn 370 calories in 25 minutes. Let's say, so if he increases his work time to 30 minutes, how many calories will he burn? Okay, so what we can do for this is we can set up a proportion. So we can let X equal the amount of calories. So this is what I can do. Okay, I can take our minutes divided by calories. And then I can set it equal to, again, minutes, 30 minutes divided by calories. Okay, so when I do that, I have to make sure that each ratio is talking about the same thing. Okay, minutes over calories equals minutes over calories. If you set it up, there are different ways to set it up, and I'll go through that here in a second, but there are also wrong or incorrect ways to set it up as well. Okay, so if you're reading through this and we have the 370 calories over in 25 minutes, that's a ratio. We're going to set it equal to the other ratio. Okay, 30 minutes and then how many calories. You just have to be careful of what you're putting across from each other and also, on the top and the bottom. Okay, so let's solve this first. Then I'll give you another way that you could set it up. So again, when we solve a proportion, we're going to cross multiply. So we're going to multiply diagonally. So we're going to take 25 times X and set it equal to the other one, 370 times 30. And that gives us 25X equals 11,100. And then divide both sides by 25 as we've done in the past. And we're going to get 444. Okay, so what does that mean? It says if he increases his work time to 30 minutes, how many calories will he burn? He will burn 440 calories in 30 minutes. Okay, so that's the answer. Now, another way that you can set it up, and probably the way that I would have done, is just taking the ratio that they gave you in the question. So 370 calories over the 25 minutes. And then when we set it equal, we have to make sure that they're the same label, right? So he increases his work time to 30 minutes. So the 30 minutes now he's going to go on the bottom. And then here, how many calories? X calories is going to go on the top. And we can see that when we cross multiply, we're still going to be taking the 30 or 370 times 30, just like we did over here. And we're still going to be taking 25 times X. So that's going to work. You could also do calories over calories. Okay, So you could take maybe 370 calories over the X calories. And then when you set it equal, make sure that, they're talking about the same thing here. So the 370 calories kind of went with the 25 minutes. And then the X calories went with the 30 minutes. Okay, so yet another correct way to set it up. You can give me an incorrect way to set it up. So here's an incorrect way. Maybe I would take the 370 over 25 from up here, but then set it equal to 30 over X. Well, why is that incorrect? Okay, so here we have calories over minutes, but here we have minutes over calories. Okay, so basically an incorrect setup, which would be when you look at the diagonals, if the diagonals have the same label, that's going to be an incorrect way of setting it up. So, all right, let's go to another example. This is a pretty common one here. So if we have a 6 foot tall person and they cast a shadow that is 8 feet long, okay, kind of represented by this right triangle here. If a nearby tree casts a 32-foot shadow, estimate the height. So we want to know the height of this tree. So what I would do, okay, or what you could do, okay, so we have this guy. Okay, so we have this guy would represent the height of the person. Okay, and then this represents the height of the tree. Okay, so what we could do is we could take 6 feet is the person, okay, over an H-foot tree. Okay, H-foot tree. Okay, and then that equals what? Well, that equals, let me use another color. We have this 8-foot shadow and then 32-foot shadow. So the person shadow. So we have an 8-foot person shadow over a 32-foot tree shadow. Okay, and that would be one way that you could set it up. There's multiple ways. So then we would just cross multiply. So I multiply these two and I multiply these two. So I take 8 times H, set it equal to 32 times 6, or you could have 6 times 32 equals H times 8, or whatever, however you want to write it. So then we have 8H equals 32 times 6 is 192. And then divide both sides by 8, and we're going to get 24 feet. Okay, so what does that mean? We have that the tree is 24 feet tall. Okay, and maybe what you want to do is you want to set it up another way. So maybe, we could do this 6 over 8. A lot of people like to do that. So they leave it in the same triangle, and then they do the same triangle over here, H over 32. That would be another way to set it up. Okay. You could also do, you could kind of flip-flop these. So you could have 8 over 32 equals 6 over H. Okay, there's also incorrect ways to set it up, right? So you could do 8 over 32 equals H over 6. That's an incorrect way to set it up. So make sure you set it up correctly, so make sure that your diagonals are not the same label, okay? And it should work out for you. All right, let's get into variation, okay? So what is variation? Well, variation is kind of how something varies, or when one quantity increases or decreases, what happens to the other quantity. It's kind of similar to slope when we're graphing. But let's talk about it. When we talk about variation, we usually talk about it in terms of an equation, okay? So let's let X and Y denote or represent two quantities. then y is directly proportional to x. We also generally normally say that y varies directly with x if there is a non-zero number k such that y equals kx. So this is our equation basically for direct variation. Okay, so this is our equation for direct variation. Okay. K is often called the constant of proportionality, or generally or normally the constant of variation. Let me give you an example. Actually, first I'm going to go through some steps. So when solving a variation problem, okay, your first step is going to be to write the general equation of the type of variation. So if it's direct variation, our equation would be y equals kx. The other type of variation that we're going to talk about in a little while is inverse. And that we would say it's y equals k over x. So you have to find what type of variation is it, and that you're going to find in the question. It will say direct or it will say inverse. Then what you do is you substitute whatever values you're given into that equation. And you find the constant of variation, okay, or k. All right. And then you substitute the value of k that you found into the general equation in step 1, and you use that equation to find the requested quantity. So let me go through an example. This one I actually gave you all the steps here, and I just left it in. I'll go through an example where we don't have all this, but let's do this. So let y be directly proportional to x, or vary directly with x. So again, your clue is that it's directly proportional or it varies directly. So right away, you know it's a direct variation equation. Okay, y equals kx. Suppose y equals 9 when x equals 6. Find y when x equals 13. So this is what you do. Okay, again, step 1, you find your general equation. Then you're going to substitute 9 for y and 6 for x into your formula and solve for k. Okay, so that's what I do here. So I wrote down the equation y equals kx. It gave me this. Suppose y equals 9 when x equals 6. So I plug in 9 for y and 6 for x. Notice here that I just switched these to make it look nicer. I want that coefficient 6 out in front of the variable k. And then I divide it by 9. So I have 9 over 6 is equal to k. So k is your constant of proportionality, or what's the other term that we give for it? Sometimes I get these confused. I want to get both terms. It's the constant of variation. Okay, so you could say k is the constant of proportionality or the constant of variation. Once you have that, you're going to replace that k value with 9/6 in your equation. So you could also write this as y equals 9/6 x instead of 9x over 6. And then you want to find y. So they say find y when x equals 13. So to find y, we're going to let x equal 13. So we're just going to plug in 13 for x here. And we see that 9/6 times 13 is 19.5. So generally what they're going to do is your homework problems will ask you for two things. They're going to ask you for your constant of variation, or k, and then they'll ask you for another thing, another value given another value. So let me go over an example. And this is on your homework. And again, your numbers might be slightly different, but suppose y is directly proportional. Okay, and again, that means it varies directly to x, and that y equals 8 and x equals 4. Find the constant of proportionality k. So again, we know that because it varies directly or it's directly proportional, we know we're going to be using y equals kx. Now I want to find k. So they gave us that y equals 8 and x equals 4. So we substitute those. So we have 8 for y and 4 for x. And again, I could write this as 8 equals 4 times k instead of k times 4. And then we divide both sides by 4. So k in this case is going to be equal to 2. So our constant of proportionality, k, is equal to 2. Now we're going to use this. So this should just say use y equals kx to find y when x equals 12. So I take my formula y equals kx and I substitute. We want to find y. We know now what k is. K is 2, and we know x is equal to 12. And when that is the case, when x equals 12, then y is going to be equal to 24. So that's it. And your other kind of variation that we're going to study in this section is inverse variation. There's also joint variation, and there's also more types of variation as well. But and also when we combine variation, but you won't do that until your next math class. But just trying to introduce it here. So let x and y denote two quantities. Y is called inversely proportional, or it varies inversely with x if there is a non-zero number k such that this is the case. So this is our equation for inverse variation. Y equals k over x. So here's an example, and again, I go through all the steps. Okay, let y be inversely proportional, or it varies inversely to x. Suppose y equals 6 when x equals 4. Find y when x equals 8. So again, we know that because it says inversely proportional, or that it varies inversely, we're going to use y equals k over x. So then we just substitute what they gave us, 6 for y and 4 for x, into the equation and solve for k. So here's our equation. We substitute 6 for y, 4 for x. And then to solve this, we have to times both sides by 4. That cancels the 4s out, and we have 4 times 6 or 24. So we know that k equals 24. Then the next step, we find y when x equals 8. So we just replace k with 24. And here's our equation. We substituted 24 for k. 24 divided by 8 is 3. So let's do a homework problem. Suppose y is inversely proportional to x, and that y equals 27 and x equals 2. Find the constant of proportionality k. So again, the hint here is that it says inversely proportional. So that means I know that I'm going to use y equals k over x. And then I substitute. Y equals 27, x equals 2. So 27 for y, 2 for x. Solve for k. We just multiply both sides by the 2. So you get 54. So k equals 54. That's our constant of proportionality. And then we're going to use our equation to find y when x equals 6. So k we know now is 54. We substitute 6 for x. And when that's the case, y is equal to 9. So that's it. Then the last thing that I want you to know how to do is I want you to know how to take a table of data. Take a table of data and tell me what type of variation it is. And I'm going to give you a pretty simple way to do this. Okay, so here's what you do. Okay, if you take your x times your y value, and all of those give you the same number. So if all of these x times y's equal the same number, then that's going to mean that that's an inverse variation problem. If all of your y, let me rewrite that. If all of your y divided by x values give you the same number, then that's going to give you direct variation. And I know this is a little backwards. Okay, we said before that when we have that multiplication equation, y equals kx, y equals kx, okay, it's k over x, and then we had y equals kx. We said that when we multiply this is direct. Well, we can see here that if I solve for k, what happens? If I solve for k, I divide by x. So k equals y over x. And in that case, it makes sense that when I divide by x, I'm going to get that direct variation because that's what k equals in direct variation. In inverse variation, what does k equal? When we multiply by x to get rid of the denominator there. So k equals xy. So again, if I have that x times y gives you the same number for every instance in the table, it's going to be an inverse variation problem. If y over x equals the same number for every instance in the table, then it's going to be a direct variation problem. So let's try that here for part A. Let's first multiply all of the x's times all the y's. What do I mean by that? I just mean 3 times 12. What is that? 3 times 12 is 36. 7 times 28. What's 7 times 28? That's 196. So right away, you know, this is 36. This is 196 when I multiply those. Okay, they don't give you the same number. So I know right away that it's not inverse variation. What about direct variation? Well, let's divide. 12 divided by 3. So take the y value divided by the x value. 12 divided by 3 is 4. Well, what's 28 divided by 7? That's also 4. Is 32 divided by 9 4? No, 32 divided by 9 is about 3.5 repeating. So this one is actually going to be neither. Okay, so neither x times y or y over x give you the same number. Okay, so therefore it's neither direct variation nor inverse. Well, let's try the next one. X times y. What's 5 times 12? 5 times 12 is 60. 10 times 6 is 60. 12 times 5 is 60. 15 times 4 is 60. So what is this one going to be? When I multiply all the x's times each y value, I'm going to get inverse variation if they're all the same number. In this case, they're all 60. Now, if I would divide, 12 divided by 5 is 2.4. What's 10 or what's 6 divided by 10? That's 0.6. So we can see that when we divide the y values by the x values, they're not the same. So this one is going to be inverse variation because of all the x's times the y's gave you the same number. They gave you 60. This one, let's take the x's times the y's. 8 times 48 is 384. What's 11 times 66? Well, it's 726. So it's not, it's not inverse variation, but let's see if it's direct variation. 48 divided by 8 is 6. 66 divided by 11 is 6. What is 84 divided by 14? Well, that's 6. And 126 divided by 21, that is also 6. So all of the y divided by x's are the same. That means I have direct variation. And they just state it a little bit different. They say that the constant of proportionality, or sorry, the constant of variation there is 6. So that means that this is a direct variation equation. When we take all the y's divided by the x's each time, it gives you 6, the same number. So let's do one more. Or let's do a homework problem. Actually, I'm going to do 2 more. Determine whether the data represent direct variation, inverse variation, or neither. So again, to review, okay, if all of the x times the y's equal the same number, then it's going to be inverse. If y over x's all give the same number, it's going to be direct. Okay, let's try it. Let's do x times y's. 3 times 16, that's 48. 4 times 12, 48. 6 times 8, 48. 12 times 4, 48. So all of those were the same. That means it's going to be an inverse variation problem. What's your constant of variation? What is your constant of variation if it's inverse variation problem? Well, again, inverse variation, the equation was y equals k over x, right? Well, all we need there is one of the y values and then one of the x values, okay? So y, let's do this first one, 16. X is 3 in that case. Let's times each side by 3, and that's 48. So it's just this number 48. I was just showing you the longer way to do it. And again, it's not direct variation because 16 divided by 3, what is that? That's 5.3 repeating. 12 divided by 4 is 3. So again, it's not going to be direct variation. All right, now let's do one more question. The strength of a metal beam varies directly with its width. Okay, varies directly with its width. That means it's a direct variation problem. So it's y equals kx. A beam that is 7.3 inches wide can support 2,400 pounds. How much weight can a similar beam, support if it's 3.2 inches wide? Let's use variation for this one first. Okay, so using variation, let's find this constant of proportionality. The thing that you have to ask yourself here is the 7.3 inches, is that going to be the y value or is it the x value? Well, way back in the early part of the semester, we talked about the difference between independent and dependent, okay? So does the 7.3 inches depend on the pounds, or does the 7.3 inches, is that completely dependent on the pounds? Well, I would say that this guy is independent, okay? So that's something that can change, okay? And it doesn't, so it's just something that changes. The width of the beam is going to, the pounds that the beam can support depend on the width of the beam. So the pounds the beam can support depend on the width of the beam. So this is a dependent variable. And this one, again, was an independent variable. Independent variables are x. Dependent variables are always y. So what we're going to do is I'm going to substitute these into our equation for direct variation. So I have 2,400 equals k divided by, times, k times 7.3. Divide the 7.3 on either side, and you're going to get what k equals. K is going to be equal to about 328.767, and it keeps going. We can just round it to maybe 3 decimal places there. And now they want how much weight can a similar beam support if it's 3.2 inches wide. So what am I going to do? I'm going to take my equation, right, just like we've done, and I'm going to substitute back in. So I'm going to say that the k value, right, we just found is 328.767, and I'm going to multiply it by that x value, 3.2 inches. Again, this is an independent variable, or x. So 3.2. And when I multiply those, I'm going to get about 1,052. And it keeps going. Actually, let me give you a more accurate answer. 328 times 328.767 times 3.2 is 1,052.0544. And they just wanted to the nearest whole number here. So 1,052 pounds. So what does that mean? It means a 3.2 inch wide beam can support 1,052 pounds. And that's it. Now, I did want to, sorry, I thought I was done, but I wanted to show you this. We could use a proportion. We could use a proportion to solve this. I don't necessarily want you to use a proportion to solve this because a question like this might ask you for the constant of proportionality, and it might ask you for the answer. But if it's just wanting the answer, what could you do? You could set it up as a proportion. You could say 7.3 inches. The label doesn't matter. Over 2,400 pounds is equal to 3.2 inches over X pounds. And then you would just cross multiply. So I would take, again, the 7.3x and then equals 2,400 times 3.2. Let's see if we get the same thing. 2,400 times 3.2 is 7,680. Let's take 7,680 divided by 7.3, and we get the same answer. It's about 1,052. So I kind of want you to use this method here with variation, but you could possibly set up a proportion. So everyone, that is it for chapter 7. That's all the new material that we will learn. I will post a review for chapter 7, and then we will focus later the following week after we finish all of chapter 7 and the chapter 7 test. We will focus on the final exam. So until then, I will see you guys next time.